Hello, my dear friends. So, today we will be understanding Netflix from a consultant's mindset. We will be doing three things today. First, we will be understanding the brief history of Netflix, the tech architecture behind the giant, so that you can understand if there is some strategy that you can implement in your software. Then, we would be understanding the secret behind the user engagement, how Netflix is applying different strategies to keep the customers engaged on different platforms. So I am excited and let's directly jump into it. Hi, my name is Rohan Girdani. I have been a tech consultant for past 11 years and today we will be decoding Netflix. So let's get into it. So my friend, the top streaming platform Netflix was actually founded in August 29, 1997 by Mark and Reed. So these friends, they open up this store, they started a business of doing rental DVDs. We had DVDs and CDs in the last era. So you would find what they do is they rented the DVDs out, they purchased the DVDs and they rent it out to customers. So the customer can just take the CD, watch it and give it back on a minimal price. So this model was working well for them. As the time passed by, they had problems with copyright, infringing, they had supply chain issues and things like that. Fast forward to January 2007, they launched their first standalone streaming service in Canada on September 2022, 2010. Now, fast forward to today, 2024. They have been launched in 190 countries with at least 260 plus million users and the net worth of more than $300 billion. So guys, they are doing well. But understand this big giant, so many services, so many devices, so many platforms, how difficult it would be to manage the tech behind it. So let's get into it and understand what they are doing correctly. So first, let's see how Netflix is powered. So they have a basic, the system is basic, but the architecture behind it is amazing. Now they have this user, you can go register, login, active membership, browse library, search out topics, cancel membership and stream videos. This is simple. So what were the functional requirements of Netflix? User should be able to create accounts, log in, log out, subscription management should be there. User should be able to play, pause video, like rewind it, fast forward, the basic video streaming services. Ability to download content for offline viewing, very important. Personalized content recommendation based on user preferences, like you see the top 10 picks for you, top trending today, things like that, the personalized content. Now, what were the non-functional requirements that were not from the customer endpoint but from the scaling endpoint? They had to work on low latency. So sometimes there could be low networks. There are various devices that are running. So these things could happen. High responsiveness during content playback. So whenever you are playing a content, nobody wants to wait. Everybody wants fast streaming. How to do that? Scalability to handle large number of people streaming directly from the Netflix server. A big task. High availability with minimal downtime. The basic requirement. Secure user authentication and authorization. Now, even if you have seen, when you go from your PC trying to take a screenshot either from a mobile phones, just try to take a screenshot from Netflix, it won't allow it. So all the security is important right now. Intuitive user interface for easy navigation. It should be very, very, very easy to use. So that is how Netflix told its requirements. So moving forward to the system design of Netflix. So when you see Netflix, at a very simpler level, it is a server, customer are requesting services, there is a network, a cache network in between that is just pulling up that data and showing it to you. But it is not that easy. Let's understand what's different. So when you go inside of it, you will see all the client devices like your mobile phone that you are streaming Netflix from, your desktop apps. So it is requesting that I need this video, I need to play Stranger Things. So it determines what are the files, the OCA server. So there is a cache server in between, the CDN in between. So let's say if you are sitting in Atlanta, USA, the nearest the nearest server to you would be used to play your service, to play your video rather than taking it all the way from their main server. So they have this cache locations at different places that you can use to play video directly on a very fast network. So even if your network is slow, you could get the local service. Now, between that, the CDN and everything, this process, every time you are requesting a service, your network is being checked. If you are on a 4G, 3G, 5G, Wi-Fi, depending upon that, it changes your pixels. That if 720 pixels would be played, 1080 HD, 360 pixels would be played. Every second, every moment, that is being checked continuously. Does that sound a little technical? Let me clear it for you. Now, when you see the full architecture, just understand, I'll go very layman. Tech is not that hard. See, this is your device. You came in, you requested Stranger Things episode season 2. You went in, there is an elastic load balancer. So what is load balancer? Load balancer makes sure if your one server goes down, it fires up another. If there are so many servers, it brings down just to maintain your cost and your availability. That is load balancer, simple. So other than AWS, Netflix is also using OpenConnect. It is also a type of a cloud that they are using. As soon as the service goes in from a ELB, it goes to a Zulu. So what is this Zulu? See, Zulu is used to divide requests. So let's say this is all the architecture behind the Netflix. So Zulu will make sure, so you say, let's say Aman or person A requested us video Stranger Things episode 2 season 2. So it will make sure where the service is coming, what is the right server or the right microservice should I send that request to, just to ensure there is right scalability and right request is going to the right point for the best result. So Zulu is nothing else than that. So when you see this outbound filter, endpoint filter, this is all part of Zulu. Simple. Then it goes to Hystrix. So what is the Hystrix? So Hystrix is another service in between that makes sure that if one service is going down, not all the services are going down. So Zulu sends its server request to the Hystrix and then it maintains the fault tolerant system here. So after the fault tolerant system, it goes to the microservices. What are microservices? Very easy. Short, small packages. So either you buy a big lace packet or you buy a small packet. Those small packets are microservices. Simple. So it is going to the microservices. It has EV cache in between. Now what is this cache? So suppose you are playing Stranger Things episode 2. There are 10 other people similarly doing that. So rather than loading everything again and again, it uses cache to make sure that the most played things are directly going to the users. Clean. After that, when it goes to, it has a database in between where it is saving data. Very simple, a database, a Cassandra database, just to make sure the systems is more efficient. These both are the databases that Netflix is using in the background. Now, my friend, what happens when there is a video coming in or video? So it is not such simple that you requested, request pass through, go to the microservice and you are sent the entire video. No. Now there is a transcoder in Amazon. If you go, you can find Amazon transcoder very easily. What this transcoder does is, this transcoder checks your network conditions, your device conditions. Now let's say you have a very low network. You can only support 360 pixels. So what it does is it divides the video into chunks. Let's say there is the full episode of Stranger Things was, let's say 1 GB. Now it would divide the video into chunks. Let's say 10 parts, 20 parts of 2 seconds, 20 seconds, things like that. So every chunk would be divided for different resolutions. Now let's say you were using Wi-Fi. On Wi-Fi, it was playing on 1080 pixels. Suddenly, your Wi-Fi is not working. You use mobile device. Your network dropped to 360 pixels for 360 pixels. So the next chunk won't be 1080 pixels. The next chunk would be 360 pixels. That is the use of the transcoder. Chunks and bringing the video as per your network conditions. Simple as that. So this video translation and coding happens. There is a queue system in between that does it step by step and then you get the video. This happens for every video that you are playing. The entire system is working like that. And then all the files are dumped into S3. Then you have Kafka events, router, Elasticsearch, They also use Amazon Spark to make it the search faster, the data searching faster. So this is how the architecture looks like. Now, looking at it, it looks a very big thing, but when you understand it, you clearly find out the things. Now, if you're working on a video streaming services or something like a data streaming services, you can definitely use some parts of this architecture. Moving forward, how does this break, process, merge, upload works? So you have to upload a video. We understood how customer is getting the video, what is the CDN doing in between, and what is going on in the background for playing it. What about the upload, my friend? So when you go inside of it, there is a process known as break, process, merge, upload. First, it is breaking into chunks. New film 50 GB. Like I told you, it is chunking that down based on the resolution. This is not the entire architecture, but is chunking it down. Goes to the queue. So there is a queue-based system, like for say let's say Amazon SQS. There's a queue-based system. You pass out all the jobs to the queue. Worker are the services that takes up the job one by one. So worker 1 would take one job, worker 2 would take another job, and then they will take job by job and complete it. So after that, you see there is a worker for 240 pixels, and based on your internet speed, 240 pixels 400 kbps, 720 pixels 2 mbps, 1080 pixels 3 mbps. So based on your network conditions, this queue, merge, upload things are divided and saved to AWS, and then it is served to you. So it is not just very easy plain, but this architecture is amazing. Yeah, but when you see from a consultant's mindset, understand this. So you will find there is a single ELB here. What I find problem here, if this ELB fails, what would happen, my friend? See, you have everything to handle the request, the Zulu server, you have historics, but what about this ELB? What is the backup plan for this ELB? Not as of now, but yeah, they might have a huge ELB, but this can be taken care of in your architectures. Now, this was about the system design. Let's dive a little bit deeper, and this is a very amazing topic that I am excited about. Let's go into it and understand the user engagement strategy. Very, very important. See, sometimes we develop these softwares, but we get to know that our software is not being used by the customers. Either they come in, they register, but they are not using it efficiently. What engagement strategies Netflix is using that you could also use? First, here you are, the Stranger Things, season 2, episode 2. Now let's see, what is the user engagement strategy? First, it is giving you personalized recommendations. So what are these personalized recommendations? So they have invested a lot of $1 billion just to develop this personalized recommendation that recommends video based on your preferences, your locality, your viewing area, your age, your preferences, the top 10, everything changes on the algorithm. It's not just a very simple algorithm just checking basic database things. It is a very beautiful thing that they are doing. So first is algorithm driven content suggestions. Second most important thing, I don't know if you have noticed it or not, the content thumbnails change as per your preferences. Same movie would show different thumbnails to different users. So let's say if you are a happy person, it would show you happy thumbnail of that video. So let's say if you have a little bit bias over politics, it would show you politics kind of a thumbnail. So this is a very beautiful strategy that they are applying, and you can apply it too. Next thing, content variety and global appeal. They have all the original content, so that is a main USP of them. Then next is localization and dubbing. No need to explain this. They are doing all the video and localization and dubbing entirely so that they can provide you the best value according to your locality. Now there is binge watching model. What is this binge watching model? They are doing full season releases. So person come in, he does not have to stop to wait for the next video sometimes. You can just come in, watch the entire series one by one. That generate that engagement is increasing because you are watching it continuously. So next is post play feature. So it will continuously play the next episode. You see it shows next episode in X seconds. That is the post play feature, just to keep you engaged so that you are watching continuously. Now Netflix is not running on your subscription, it is running on your engagement. So this topic is very important to understand. Every software is running on engagement, not on the price money. The next feature, the notification and personalization. You will see emails and notification personalized to your preferences, that this series is coming in. Tell me a reminder for this. This is the another engagement strategy that they are following. Next is content discovery. In content discovery, you will see, now you can see in your platform or your device or your mobile phones, there are multiple categories coming in. Curated categories, top 10 lists, things like that, so that you can see the best of best according to your preferences in the platform. So this is the curated categories just for you. They are curating categories, the titles according to your preferences, even the top 10 list. Next engagement strategy is social proof and FOMO. Now, what is this social proof and FOMO? So they create a social buzz around their content on different platforms. So you see this thing is coming and you get interested. You go to Netflix, you watch it. They run ads even for that. Now, when there is exclusive content, there is a fear of missing out, that your friends are watching, your colleagues are watching, but you aren't watching. So this is another strategy that they are using. Now see, they are doing a very smart game. They have solidified their architecture. Now they are engaging you in a process that you are continuously coming back. Now what they also have another strategy known as user generated engagement. Now what is this user generated engagement? First, they have interactive shows. Now you have seen that Netflix has started launching interactive shows where you can take action, yes or no. Like there was one show for Bear Grylls. You can go inside, you can take action, you can interact with the video. So that is interactive shows to increase polls and viewer participation. Next is continuous innovation. You have seen they have introduced shorts. You can view the shorts, the laughs. So they are doing continuous innovation and trying things out, and mobile specific content is also being published separately. So when you go to desktop versus your mobile phones, you will see separate contents. Next, the retention strategies. The content release scheduling is done in such a way so Netflix always has new content. You are never out of the series and the movies when you are on Netflix. Similarly, they have another strategy where you can pause your membership so that you don't have to cancel. So they are stopping you from canceling your membership. Just pause it. Continue it on the later time when you feel comfortable. This is a very beautiful strategy that they are doing. Now, looking at all the things, how they started, what were the requirements, the system design, the architecture, and the content strategies. I hope this added value. And if this added value, make sure you like it, subscribe it, and give a thumbs up. See you next time.